Welcome back to the 8th section of Chapter 1. In this one we're going to be looking at exploring transformations. Transformations is something that pretty much all of Algebra 2 is based around. That's where we're going to be moving functions. We're going to be starting with parent functions, which we'll get an introduction to next time, and we're going to be moving them and changing them into all the other different types of functions in that family. And so this is definitely something we'll be building on. This is a quick introduction of it, and it's kind of weird. Like, the rules here aren't quite the same for the rules for the whole rest of everything else, but when you look at it, it's actually a pretty easy topic, but I don't expect everyone to fully grasp everything right now, or even in Chapter 2. But when we do it again in Chapter 5, Chapter 6, Chapter 7 twice, Chapter 8 twice, Chapter 9, you're going to get it by the end of the year. And I understand it's a growing process. So let's look at our learning targets. I can apply transformations to points and sets of points. And I can interpret transformations of real-world data. So what's actually happening here? So in our transformations, we have 3 big transformations that we're going to be working with this year. We have translations, which are slides, so we're just moving something from one place to another. We have stretches and compressions, which is stretching or compressing. I think those words are actually used in English enough that we know what those are. Stretches, it's getting bigger. Compressions, it's getting smaller. And reflections, which is where it reflects or mirrors itself. For translations, we're going to add or subtract to get from one to the next. With stretches and compressions, we multiply. I'd say multiply or divide. We just multiply. We don't divide with that. And reflections, we're going to multiply by -1. And so each of these is going to have both a horizontal and a vertical component to it. In the horizontal component, we're only going to work with the x variable. In the vertical, we only work with the y variable. Today, since we're just working with points, we'll either work with the x part of the point for horizontal or the y part of the point for vertical. And so, looking just at transformations now, if we start out with a point, just the generic x comma y, if we want to move it so many units horizontally, we're just going to add that number to the x. And the variable that we use for that horizontal movement is h. That makes sense. X plus some number, comma y. And we'll see an example of this in a second. But for vertical, we're going to do the same thing, except we're going to add it to the y. And obviously the variable we use for vertical is going to be k. Alright, that's not obvious. I don't know why we use k, but we always do. We will throughout the rest of the year. We will in formulas. Like, it's h and k. Not entirely sure why, but that's what it is. So, looking at an example, if we want to move the point 2, 3, 1 unit up, or 1 unit to the right, and 4 units up, we have a horizontal translation here, 1 to the right, so we're going to go x plus 1, and a vertical translation here, 4 units up, so y plus 4, and so 2 plus 1, because 2 is x, that's just 3, 3 plus 4 is 7, our new point is a point 3, 7. Are you always going to do both horizontal and vertical at the same time? No, you can only do one or the other, but with translations, a lot of times we do both horizontal and vertical at the same time. That won't necessarily be true with stretches and compressions or reflections. And so what this did, it just moved this point, 2, 3, took it from its point, moved it 1 to the right, and 4 up, and we're at the new point. That's all a translation is. For stretches and compressions, again, we're going to start out with the point, x, y, and we're going to multiply these values. Horizontal, we're going to multiply to x. The variable we use here is b, so it'll be b times x, y. Vertical, we use a, x, a times y. And so we're just going to multiply the number. Now you might be asking, all right, so how do I know if it's a stretch or compression? Well, that's a very good question to ask yourself. And really the only difference is what number are you multiplying? A stretch is going to be if A or B is bigger than 1. So if you're multiplying by a bigger number, it's going to get bigger. A compression is if it's less than 1, but bigger than 0. And here I have A, but that works for B as well. Both of them have the same rules. So it's a compression if it's less than 1, but bigger than 0. What about if it equals 1? If you multiply by 1, you're not doing anything. That would be a nothing. What if it equals 0? Then everything becomes 0. And that's not actually a transformation. Transformations keep the same basic shape. You might be stretched or something, but when you multiply by 0, everything just collapses to the axis. What if it's negative? Well, then you get into a reflection. If it was, say, like -2, that would be a stretch of 2 and a reflection. So those two can combine. Now with these, we could do both horizontal and vertical stretches or compressions at the same time, but generally speaking, we don't. And so let's look at a horizontal stretch. Stretch the point 2, -3 horizontally by a factor of 4. So it's horizontal, which means we're looking at the x value. We're just going to multiply the x value by 4. So 4 times 2, -3. 4 times 2 is 8. So you have 8, -3. And then, how about stretch it vertically by a factor of 1/3? So 2 times 2, -3 times 1/3. -3 times 1/3 is just -1. So it's just the point 2, -1. And then reflections, we multiply by -1. So if we have, by the way, this one was a stretch because it was bigger than 1. This one was a compression because it was less than 1. We do the same thing to it. Stretches and compressions are differentiated simply because when you stretch it, it would sound weird calling that a compression. Same thing with backwards. That's why they have the two different names to it. But you do the exact same thing. All right, back to reflections. We start out with our just random point, x, y. Horizontal, we need to make the x value negative. Vertical, we need to make the y value negative. Now the trick here is knowing which is which, because it generally won't tell you do a horizontal reflection or a vertical reflection. It'll say reflect across the y-axis or reflect across the x-axis. If you reflect across the y-axis, that's a vertical axis, your reflection is going to go this way. It's like looking in a mirror in your bathroom. So the reflection goes horizontally. So horizontal is probably going to use the phrase y-axis in the question. And vertical will use the phrase x-axis in the question. And so that's confusing, or it's tricky, because you see x-axis, you think, oh, it's horizontal because of x. It's going to be backwards, because again, reflections are going to be perpendicular to the axis of symmetry. So we have that if we wanted to reflect the point -4 or 5 across the x-axis, that's a vertical reflection, so we have to make the y value negative. So that just becomes a -5. So we get -4, -5. If we want to reflect that same point across the y-axis, that's horizontal, so we need to make the x value negative. It's already negative, so it just becomes positive, 4, 5. And so these are the transformations that we're going to be looking at. A lot of what we see here will stay the same throughout the chapter, but there are a couple changes when we're not working with the points themselves anymore, and we'll see those in the next chapter. Anyway, that's all for this time, and I'll see you again next time.